Gas transport is mainly transportation or movement of gases to the bloodstream, and how, or their just transportation or their just involvement. So, gases, either oxygen or carbon dioxide, transport through the blood in one of either two mechanisms. Firstly, we will begin with the oxygen. It can be either oxyhemoglobin, which is a combination formed by hemoglobin and oxygen, and it is like 80%, 98% of the times. So it is the most common form of the oxygen transportation. The other form, which is dissolved O2 form. The dissolved O2 form is like, it is seldom, it's rarely happening. So, properties of the combination of oxygen and hemoglobin, which is oxyhemoglobin, the common form. It is a reversible reaction, as we mentioned before. The reaction is super rapid, requires less than 0.01 second. So it's just a tiny period of the second. It occurs even before the oxygen reaches its equilibrium. The reaction is oxygenation, not oxidation. So, factors affecting the affinity of hemoglobin to oxygen. Affinity meaning like the binding or the ability to bind. pH decreases, and the pH results in decrease of the affinity of hemoglobin to oxygen, so it is directly proportional. Decrease, increase. Temperature, increase in the temperature result in decrease of the affinity of hemoglobin to the oxygen, so it's inversely proportional. And finally, the partial the PCO2, or the partial carbon dioxide, the partial pressure of carbon dioxide. Increase in the PCO2 result in decrease of the affinity to hemoglobin to bind to the oxygen. It is like it's inversely proportional, like the temperature. So the second form, which is the least common form other than the oxyhemoglobin, which is the dissolved O2, the concentration of O2 is directly proportional to the partial pressure of O2. The amount of dissolved O2 is in linear function with the partial pressure of oxygen. Now we will switch to the carbon dioxide. All of the previous talk was mainly about the oxygen. Now switching to the carbon dioxide. It is transmitted in blood and plasma. Not only blood, but also plasma. We mentioned earlier that it's in the blood, but carbon dioxide goes to the plasma. In RBCs, carbon dioxide dissolved in intracellular of the RBCs, or red blood cells, combined with amino group of hemoglobin to give carbamune hemoglobin. The second way of transportation, which is in plasma, carbon dioxide dissolves in plasma, combined with amino group of hemoglobin to give carbamune protein, not hemoglobin as in the RBCs. And this figure shows like a general process, the gas exchange and transportation, inhaled and exhaled, which describes the ventilation and breathing in general. And now we will go to the regulation of ventilation.